We've got Piyush here. He's going to be talking about MCP, and it's a big old long topic with lots and lots of stuff. So let's go ahead and get started. Over to you, Piyush.
Hello, everyone. Good morning or good evening, depending on where you are. My name is Piyush. I work with the ColdFusion engineering team as a quality engineer. Over the years, I've worked on a lot of features. I'd say mostly performance, various cloud features, licensing, and more recently, uh, me and my team has been working on a lot of AI-related features. In particular, I've been working on MCP, which is what the agenda for today's presentation is. So let's get started. Let me walk you through uh, a brief on the way, the layout of the session. So we'll start with a brief introduction on what MCP is and how it works. Uh, then we'll go through a very quick, simple example, sort of a hello world example of how it works with ColdFusion, the way we are integrating MCP with ColdFusion. And then we'll talk about the different kind of configurations. So when we talk about MCP, there are different kind of entities. There's always a MCP server and a client in an MCP related application that you might have. So we'll talk about what kind of configurations your MCP server or your client can have. Then we'll talk about MCP, different kind of MCP related functions that we've introduced in ColdFusion language. So basically, whenever you're using ColdFusion, you would be familiar with what we call a built-in set of functions, built-in functions that you can call if in your typical CFML code. So we'll talk about what those functions are that are related to specifically MCP. Now, MCP in MCP's paradigm, there are a lot of entities or features that are very kind of obvious or are there that are very relevant in terms of the kind of functions they provide. So we'll talk about those features primarily for a good part of the session. Uh, so tools, for example, is a very useful and the most primary use case for MCP. It's a feature. We'll talk about that. Then we'll talk about resources, which are nothing but files that your application can expose. And we'll also talk about prompts, a little more on that in the slides up ahead. Then we'll talk about features like sampling, logging, elicitation, routes. So we'll talk about I'll talk more about them when we cover them. And then there are some aspects that are related to everything in general, which is like the kind of security related features that any of these features might have and how we are handling it in a typical ColdFusion MCP based implementation. We'll talk about those. And then we'll talk a little about finally on how you set it up. And if you're using ColdFusion, you'll be familiar with the administrator, ColdFusion administrator, which helps you with a lot of different settings at a high level. So we'll talk about how MCP is handled in that context, along with the admin API. And finally, MCP at the end of the day is something that enables your LLM that you are familiar with now, and how it would integrate with an LLM. So basically, how your application would leverage MCP when it is making a service call to LLM. And then, of course, we can have some questions if you would have need any clarification, right? So the presentation will mostly be will have an application that will go through at the end of the presentation. Uh, the application would basically be, think of a typical use case. So if you want to understand MCP, let's take a hypothetical scenario of, let's say you've got some sort of a support system where you are processing a lot of tickets, let's say trouble tickets or technical issues, related issues day in and out. So let's say you've got a technical issue and a ticket comes in with a certain set of log files and a basic issue statement. So you need to process that by providing a resolution, analyzing the log, trying to classify what is the urgency of the ticket and those kind of things. So you've got to take a set of decisions, you've got to analyze it, and then you need to process it, triage it in the sense that you either resolve it or you send it up the chain for further evaluation, right? So we'll see in the context of MCP how MCP can be useful in processing such a scenario, right? Right. So let's start off with the basic understanding of what MCP is. MCP is basically, you can say it's an open standard protocol that enables your system to talk to an LLM. It standardizes the way your system, let's say your application can talk to LLM. So let's say the most basic use case is, let's say, everybody I'm sure will be familiar with using ChatGPT, right? So when you're writing down a simple query, in that portal, you're making a call to an LLM, and it's the LLM is kind of trying to help you out with your queries, resolving it, giving you an answer. Now let's try to widen that context. Let's say your problem statement is a little has a lot of more information. So let's say you are using an application, and the application, let's say, can make a query to that LLM service. So that application can have a lot of different things that it might need to add to that query to make the LLM work on that solution in a more comprehensive way and give you a better resolution, right? So that is what MCP does. So MCP basically provides you with a mechanism of supplying a lot more context to that LLM service. And not only that, so if you have a set of services and you want your system to be accessible to the LLM, so you can have an MCP server in your infrastructure that can actually talk to the LLM and give it information that it needs. So a typical application of a typical example of an application can be anything from a chat interface or an IDE that you're using to develop code, right? So that can have what is called an MCP client embedded that can make a call to an MCP server. So let's say you've got a legacy system where you have a lot of data, right? So you can have an MCP server sitting on top of it that can make the data in it accessible to an MCP client. So let's say there's an application that I've developed that solves the problem using AI related features. So it will use an MCP client to talk to, or rather to access the data that you are exposing from your older infrastructure. So you got, uh, let's say in the context of this health support system, you've got a lot of KB articles or a lot of let's say logs and such that you want to be able to expose to the LLM, right? So the client can actually, you can have an MCP server sitting on top of it that gives you functions, allows for functions that can expose that information, and an application that is trying to use that information in an intelligent way will use an MCP client to fetch that information. And not only that, that MCP client can basically make a call to LLM, and the LLM can also directly invoke the tools that are registered with that server. So we'll take a look at how that works. That'll be a little more clearer once we go through the individual features. At a very high level, when we're talking about dealing with MCP, we have the server entity and the client entity, MCP server and MCP client, and each of these entities have a different set of let's say features available to them, right? So when you have a server, you can have features like tools, resources, and prompts. We'll talk more about what they are. And when you have a client, you can have capabilities like sampling, elicitation, and routes. It'll be clearer when we talk about those features in detail. Now, an MCP client would basically be able to expose these features, and it can basically give you give, let's say, the services that are accessing it an option to list the tools. So let's say the MCP client will always be plugged into a server, and the server will have things like tools, resources, and prompts, right? So an MCP client that is connected to a server will in turn expose methods or APIs like tools, list tools, or crawl tools to the LLM, so that the LLM knows what tool to call ultimately. And all the let's say communication that takes place between a client and a server, it uh, goes in a protocol which is called JSON RPC, which is nothing but like a different form of a JSON communication. So there are two different ways in which a client and a server, an MCP client and MCP server, can talk to each other. One is the good old HTTP protocol, in which the communication happens with the JSON RPC data format. And then the other one is the STD, which is the standard input output, which is the most basic form of communication that happens within, outside the context of a network. Let's say if the both entities are located on the same host, right? So you need not go over HTTP. You can directly invoke the entity over uh, normal process, OS related process pipes, you could say, right? So now here's a typical life cycle of, let's say, when an MCP related process, or let's say is initiated. So here you can think of host as not really a classical machine host. It is mostly an application, an AI based application. So the host here is an AI application that has an MCP client, that is using an MCP client, and MCP server can be an external entity that is hosted on a remote host or a remote machine, and this client will talk to the server using either of the two protocols. Mostly, if it is remote, then it will be using that HTTP JSON RPC protocol. So when the AI application spins up, or let's say it starts up for the first time, it instantiates a client object. The client object will basically be configured with a server. So a client object will always have some sort of a server kind of configured with it. So when it starts up, it will kind of initiate that communication with the server. It will initialize it. So client always, when it makes the first call to the server, it advertises what kind of capabilities it has, right? And the server responds in kind with the kind of capabilities that it has, so that they are both well aware of what or how they can make the best use of each other. And then once that is out of the way, the typical operation that happens, basically this part, the part in the middle, will happen in a loop. So it can make a request for information or tools or resources, and the server can respond with whatever tools that it is using, with the whatever the tools is supposed to return. Tools here is nothing but a function. So it's a, you accept some input and you return some output. Resources likewise is some sort of information in the form of files that it can return, right? So all that happens, and once the application has done it and it needs to shut down, or it's you're stopping it. So that typically involves closing the session itself. So the client object has a close method that you invoke to stop the communication, that effectively terminates the client object's uh, life cycle, right? Server, of course, can continue to function unless you shut it down or you stop the process. Right. So that's your typical life cycle of how an MCP client communication happens within the context of an AI application. AI application, MCP client within the same runtime, talking to a MCP server on another part of the world, maybe. Okay. So let's start off with the most basic example of how you'd be using an MCP based application in the context of ColdFusion, right? So ColdFusion, everybody is familiar with what an FCFC is. It's the most basic form of functionality that is encapsulated in the form of a component or a class, you could say. So I've got the most basic example of a CFC here. It's something that just accepts a message and echoes it back. Now, let's say we want to make this tool available as a uh, make this CFC available as a tool to any MCP server. So what you'll do is typically wire it with the MCP server here by using this particular statement here. All you have to do is specify the location. This is nothing but just the relative path of this CFC, which is called echo tool CFC in this case here. And you just advertise its capability as by setting it tools value to true within the capabilities config here. That's it. And you call this method that starts the server's lifecycle, right? So as soon as you instantiate this part, it will make an HTTP call to this particular CFM, which is here, and it is good to go. Anything that is using this can actually, invoke this function and get the response that it is returning back. But to show you an example how the client would work, right? So the client here would be configured with your MCP server that we saw in the previous slide. It is the CFM that we saw for the server, and they all have their own properties. Client will have a name. It's an optional thing. And then you can invoke functions like list tools, and you can call a tool, and it will return the object in the form of a struct. You can decide how to return it, but in this case, you can see that it returns this hello output. So that is how the most basic thing would work. Uh, this thing connects it to the server. List will basically be sort of a discovery. So you just have the example of I'd say it's just printing the number of tools here, but you can print a lot more. So you can uh, the information you get with this is basically the name of the tool, the kind of input it takes, the kind of output it returns, and uh, those things, so that you know how to use the tool, right? So that is returned to you in detail. And once you're done, you can close the session here. That will terminate the connection, you can say. Right. So that was the most, I'd say, rudimentary example of how a tool which is the most primary feature of in the context of MCP that you'll use in ColdFusion. Now we'll go through each of the configuration in some detail before we talk about the features. So let's get ourselves familiar with the various configuration settings that an MCP client and an MCP server can have in a typical ColdFusion application. Right. So we'll start off with the MCP server configurations. Every server will need to have a name and a version. It's mandatory. So when a client makes a connection to it, it has access to this information, which what is the name of the server, or what is the version it is talking to. Internally, you can have that version for as, as some sort of a versioning system where you are coming out with different incremental changes in your service that is widely used, maybe, right? Now, like we talked about earlier, a client and a server entity can have its own set of capabilities. So for MCP server, these are the capabilities that it can have, and the way you set it uh, as uh, as available or advertise it to a client is by just setting these as Boolean values in this struct here. And you've got something called CFC caching, which is how a typical caching works at a typical, I'd say, component at the ColdFusion level. So if you make any changes to the CFC that is behind your tool, it won't take effect unless you either, let's say, restart the server. Or in this case, if you just set it to false, those changes will be automatically reflected. So obviously, you would want to have this enabled if you're using it in production, right? And then you've got something called reload config on page refresh. Now, this is something that is applies to the server entity, or the server CFM itself, right? So when you call that handle request method that we saw earlier in this previous slide here, that actually kickstarts the server lives servers, that brings the server into existence, and that page can it be accessed by multiple clients. Its behavior will stay the same, but let's say you make some changes to this server within the server CFM. The change won't be reflected unless you have this thing set to true. So if you have this particular setting set to true, it means every time this thing is hit or the server is invoked or called, it will kind of reload it, right? So ideally, you would set it to false unless you're using it for development, right? And course is something that is a bit sort of a security setting that lets your, by default, you can only access the server within the same domain, or the if you're using a browser. So you have an option of using this if you want to allow other domains to be able to access your MCP server. By browser, I mean within ColdFusion, maybe it's not very, but if you're using HTML, JS, or some other sort of code that actually can directly access your MCP server, right? Directly using JS scripts, maybe, then it makes sense for you to use these settings, right? Right. So there's something called methods config, which is nothing but a different way of registering your tool with the MCP server. So like I showed you in this slide, all you have to do is specify the CFC, the in the form of a relative part for that component in that ColdFusion server, that basically would expose all the functions in that CFC to the MCP server. So let's say you've got this MCP server, and then you've got the echo CFC that we saw. If that had multiple methods, it would expose all the methods. Now, all the methods that are available or rather they are configured as a tool with an MCP server, they need to be remote and they need to be public. Obviously, a remote method would always be public. So uh, those methods need to be remote to be able to be used as tools. Without that, it wouldn't work, right? So any CFC that is registered with the MCP server in this manner with the tools parameter, and of course it's an array, which means that you can register multiple CFCs within this configuration. So all the remote methods within that CFC, or those CFCs that are registered here, they all will be available to the server. Now, if you want to be a little more restrictive in terms of which functions you want to allow and which you not want not to be available to the server, then you can use this particular notion, which is the methods config notion, where you explicitly call out the methods that you want the server to be able to access, right? So that basically blocks out even remote functions that are not specified here. Even if your CFC has those remote functions, they won't be exposed. Okay. So you need two parameters, just the name of the method as well as a description, which is kind of optional. Right. So when you do a listing, you can see the description there. Right. So now, moving on to the prompts. So prompts are nothing but they're like reusable templates. So when you're using an LLM query, when you're querying an LLM, uh, you typically have to type the user query that you have, right? So now you think of it in terms of an AI application. You'll mostly be reusing the questions repetitively, right? So it makes sense for you to have some sort of a common template that you can register right at the server, and you can query the server. The server will return you that template, and you can simply use that MCP client can query the server for the kind of prompts that it has, a repository of prompts or a set of prompts that makes sense for that server to have. You can query for that prompt, and you can place it with whatever you want. You've got placeholders here that you can replace it with, and then you can make use of those prompts in your LLM calls. We'll have a prompt section where we'll talk in a little more detail about how to use it. Likewise, for server, you have resources. It's something like these are nothing but files that your server can expose for use to give the LLMs a greater context. So let's say if you've got a lot of logs or documents that you want a typical client to be accessible, right? So an MCP client can actually make a call to your server, get those resources, and in its LLM queries, it can leverage those resources. So the typical file, it will have a MIME type. You can have JSON, PDF, and data like that. Whenever you're registering a resource, you need to provide a mechanism for the server to be able to access that resource. So you do that by using a closure or a function that can basically just read that content and give it back to it, right? So you will always configure a URI, which is sort of a unique entity that uniquely points to a particular resource, and the rest of it is optional. So URI and resource handler, that they need to be there for it to be able to expose this resource to MCP client. Right. So from those were the three things that we talked about here, the three server configuration: the primary server configuration, the configuration related to tools, configuration related to prompts and resources. They were all server related features. Now we'll move on to the client side of things. For the client, the most basic feature, of course, was going to be the transport protocol that it is using. Transport, like we saw earlier, can be only of two types. One is HTTP, and the second one is STDIO, which is the standard input output. So for HTTP transport, you always need a URL which tells the client where the server is, basically. And when this client is making a call to the server, if you have headers specified here, uh, with those calls, it will always inject these headers. So you might find this useful for some use cases, right, where you need things like authentication and stuff, right? And client will always have a name, so uh, which is optional, but it's makes sense for you to have it, because sometimes your server, an MCP server, would like to know the name of the client that it is talking to, and you can base your the server can base its logic based on that, right? So you can use this client info configuration parameter to set your those settings, right? Now, STDIO transport protocol, on the other hand, it's something that stays within the system, confines of that OS or that system. So it basically is nothing but a process, right? So the parameters that it accepts would be command, the arguments that go when you're executing the command, and there's something called command whitelisting, which is something of a security feature. So if you look to the right in the code sample, this is, let's say we've got a Java-based MCP server which is on the same machine, which is in the form of a jar file, right? So the client needs to talk to that server. It will spin up its own instance of that server, or rather, when I say instance, I mean a process of that server, right? Or if you're using TypeScript, this is how you'll do it. Now, if you need to pass some parameters within with the process when you're executing that command, this you can use this args parameter to specify that, right? So ColdFusion obviously only supports HTTP based servers. So you can have your MCP client in ColdFusion application, and you can have your MCP server in a ColdFusion application, but you can only have HTTP based MCP servers in a ColdFusion application, not STDIO based applications, right? Okay, so just like we talked about, HTDIO is local to the system. It spawns processes every time you invoke a client, or rather, not invoke a client, I'd say, and every time you instantiate a client with this, when you this is basically this API or MCP client API is creating a new instance of a client, right? So that starts this process every time you uh, make this call again and again, it will start a new process. So obviously you'll be reusing this object rather than creating multiple processes for the clients, right? So every call makes a client makes a process, right? And of course here authentication and those things don't apply, because everything is within the same host or the same OS, right? All right, so let's move on to the client capabilities. The client can have some capabilities of its own, sampling, elicitation routes. Those are the primary capabilities that the client can have. We'll talk in a little more detail about what they actually mean. In very brief, sampling is something that enables your server to make an LLM call. So, uh, server is nothing but it gives you information, or gives you a set of, let's say, data or information that the client can use to make intelligent queries to the LLM, right? And in case of tools are something that the LLM can directly invoke and get the information directly. But let's say your server itself sometimes makes needs to make an LLM call. In this case, what it can do, it can leverage the sampling feature. So if the client supplies a sampling feature, it means that LLM can actually make a request to the client, sending it a sampling request. The client can take that request, make that LLM call maybe, and then return that information back to the server, right? So that's a good use case. So for example, you can say that your your MCP client is requesting for server for some information, and that server, let's say, it needs some additional information to service that context, right? To service that call, then it can make a sampling call back, right? So sampling is about that, and elicitation is more about asking for additional input for the from the client. So let's say your client makes a call to the server needs some additional input on or clarification on what to do, then it'll make a simple elicitation request. The client can respond back to the server with the requested information, and server can do it can proceed with fulfilling the servicing the request that the client originally made, right? Now roots is something which is a little more interesting. So it's roots is nothing but a way for clients to expose its file system. So a client can also expose directories and files within its host, or within its purview, to the server. So this is what that mechanism allows. Now we'll talk, of course, in more detail about these things. Uh, Simple setting, of course, is initialization timeout, which means that when you're instantiating, starting up a client, it's making that first call, initiation call that we saw in that life cycle diagram earlier. You can set a timeout to it, of course. So if the service is not even up, of course, there's a limit to how long you want to wait for that. And subsequent to the initialization, every time a request is made, you can set an upper bound to the time that uh, you want that request to wait, right? And then you've got callbacks that you register. So let's say uh, logging is another feature. You could say logging is something that server exposes in the terms that server can generate logs, and it can send that logs back to the client. So if the client has a logging consumer configured, it can do whatever it wants with that information. So server will send all the log entries, and your client can log all that, or we can use it for your own whatever purpose you need it for, right? Likewise, for sampling elicitation that we talked about here, you need to have a consumer, or rather a function or a closure that actually services these requests. We'll talk a little more about how that works in the subsequent slides. There's also something called tools change listener, which means that on the server side, if there's any change in the tool that it is advertising, right? Then if you have a tools change consumer configured at your end on the client side, if there's any change that happens or that with the nature of the tools, or if you add an additional tool, then it will make a call to the tools change consumer listener configured with the client to inform you or intimate it with what the changes were. So you can use that if that is relevant to you. Right. So we've talked about the basic configuration for a server and a client. Let's now talk about the different kind of headless functions that you can use related to MCP in a typical ColdFusion server installation, right? So list tools is something that you would call, it's not really headless, you could say, but these methods are basically called against the client object that is connected to a server. So once a client is connected to a server, it can call the list tools to see what tools are available. Of course, before you do that, you can call the is tool supported method to know if that server supports tool, and if it does, you can list the tools and you can invoke the tool by using call tool, right? So it works the same with all the other things here, list resources as well, and the same for prompts. Okay. Now, other than that, you've got roots. So, like I mentioned earlier, a client can have roots, right? So, roots are nothing but directories and files that the client can expose to the server, right? So, the way it does it by adding the roots, so you can call a add root method against the client to add those directories you want the server to be able to access, right? So these are the methods that you basically use for adding or removing the roots with the client. And these settings basically are there for related to logging, which means that if logging is supported on the server side, then you can call this method to find that out. And like I mentioned earlier, you can register a logging consumer handler at your end, at the client's end, right? So whenever server is sending any log entries, you can write it out at your end. But you can use this method to set a filter to what kind of logging level you want to receive, right? So you only want to maybe process those logging entries at that level. And we've talked about the tools change consumer and resource change consumer listener earlier. So those were the client related functions. Now we've got some very basic server related functions. Now server, unlike clients, the servers are something that are kind of maintained in you could say, a registry within the ColdFusion runtime. So every time you create a server, that gets registered with a unique name and a version number combination, right, within the server. So the next time you call MCP server with the same name and the version information, you get an instance of that server. And if you want to see how many servers are being run in within your ColdFusion runtime, you can use this first method here, list MCP server. It will give you a list of all the running servers, or rather servers that are existing in within the ColdFusion's runtime at that instance, right? And if you want to purge any server, you can use the remove MCP server method to remove that server out. And if you want to find whether a certain server exists or not, you can use the MCP server exists method. Right. So we'll talk in a little more detail about how tools work. Obviously, the marquee feature of an MCP service is tools, which is like gives you a it lets you create or configure any component with any kind of functionality. So let's see how that works. Right. So like we discussed earlier, this is how you register a tool using a CFC, and this here is the relative part to the CFC that is actually going to be made available to this server as a tool. And we've talked about these features in the right earlier, so let's just skip through that and see it in the context of a ticket process. So let's talk about that simple application, that, or rather the use case that we started with, right? So let's say you've got a system that needs to process tickets right now. Let's say you make an LLM call to find out what kind of what you can do with a certain trouble ticket that's coming in, right? So of course that LLM might need to know the ticket details, right? So you can register your ticket processing method that has a function that actually returns the ticket information, right, based on the ticket ID that you have, right? So if you register this as a tool with your MCP server, the LLM can actually just have the you can raise a query giving it the ticket number, and the LLM can then inquire back, or it can make a query back to your tool asking it for the details of this ticket. So and likewise you can have an update ticket method, so that once it is done processing that ticket, it can send information back to this tool to update the ticket related information here, right? So that's how it typically works. And like we talked about earlier, there's that methods configuration that lets you selectively configure things. So let's say if you want to expose only the get ticket method and not the update ticket method, you use this explicit methods configuration, where you specify just this method and not the other one, the update ticket one. This method, on the other hand, it will expose both the methods to the server, since they're both remote functions, right? First and the second. Right. So this we've already talked about. When you're registering it, you use the methods and the descriptions uh, configuration parameters, right? So and this is how you'd be calling it. So let's say you've got this server, this client instance is connected to this specific server that we've created here. Let's assume that this server is going to be this CFM, behind the CFM. Then you can do a listing, and it will return you that the names of the tools, and you can see what that looks like here. So let's take a look at how it looks in real time. Right. So here we've got an example of tool. So let's say I've got an MCP client that is connected to, let's say, a ColdFusion based that Echo simple example that we saw earlier. Now, if I hit a list tools request, it basically gives you listing of what tools it is exposing. So echo tool is the name of the tool, and this is you could say a description of the tool, right? And let's say you want to invoke this tool. This output that you see here is written by the list tools method. And if you want to invoke that tool, we can use this particular thing, which will send the information to the tool. So let's say the tool here is echo message, right? So we'll use that name. We want to invoke this tool, and we want to pass it this information, right? And we can call that tool, so it returns that the response back, which is that CFC is returning this information. So if we take a look at the backend, maybe if you would like to see how that works, let's go to the demo app here. Right. So this is your client, so rather the tool. This client is making a call to it, and then let's say the server is here, right? So MCP tool server, right? So this registers this tool here, and the client then it makes a call to this, and this method is probably somewhere here. So that is in CF tools, right? So we'll see this is the echo tool here. So it's returning it in the form of a struct. You've got success depending on whether you've passed something or not. And then it says this message from the server, right? So that is what we saw here, right? So message from the server, right? So, right. And so ColdFusion, of course, you can have not just a ColdFusion client can talk to not just ColdFusion based MCP server. It can talk to other any kind of server, right? So let's here's an example that uses a TypeScript based server, which is has a bunch of tools apparently. So you can see you've got one, two, three, and many other tools. So let's say you want to query what kind of server information is returning here. So you can see that this tool basically returns information about the server. So we talked about those two parameters. You set a name for a server and you set a version for the server. Apparently, this tool is running on a server called tool server, and it has this version, right? So that's how basically a typical tool listing and invocation works, right? So okay, let's go back. Okay, so moving on to resources, right? So resources are something that as we've discussed, they are basically files that your server can make available to the clients, right? So you it can be anything. It can be a static file, it can even be an HTTP based file, right? Typically you'll have things like JSON, logs, PDFs, and whatnot. So let's take a look at the example here. Okay, so here's how you'll expose the resource, right? So resource would have these properties. I think we've discussed this in the configuration slide as well. So you always need to have a URI for the file, which is like a unique. It should be if you have multiple. It's an array, of course. So you can declare multiple resources within this uh, server configuration, and in that array, every element should have a unique URI for that file. And then all those files that you're exposing, they need to have something that lets the server read it, right? So you register the file handler within it. Okay, now you also need to specify the MIME type of the file that you are registering with your server, and a brief description, which is optional, of course. And of course, well, if you're configuring resources with your server, you would advertise that capability as true here. All right. So, okay, moving on to the client side of it. So that was how you declare it in a server. Within the server, here's how you register your resources. Now, as a client, when you're talking to this server and you want to know what resources it has, here's how you do that. So MCP server connected to that. Sorry, MCP client is connected to that server via HTTP, and it can make a query for is resource supported or not. So if it is supported, it can proceed to list the resources, just like your uh, tool related APIs. You find out whether it's supported, then you list it out, which gives you a bunch of details about the resource, and then you can make a call to read those resources. So it will return you the content. So this is when you invoke this read resource, it basically invokes your a resource handler here. So it will you will get what this thing returns here, right? And then the response that you get basically contains information like MIME type and data. Okay, so let's take a look at the example for this, right? So resources, so let's check out the sample here for resources maybe. So here's your resource server that we saw there. We are listing only one resource here, which apparently is a log file behind this URI, which is I think registered at the server here somewhere. Right. So I think, yeah, this is the URI basically for the resource, and CFM is doing nothing but reading it back and returning it to the UI here, right? So, mm, all right. So we saw that log file. So let's run that. So that's your server behind with which that resource is registered, and since it has, as we saw, a single resource registered, it's listing the URI for that resource along with the name of the resource, I believe, is what we are printing here. And if you invoke this is the contents that is written, this is the content that is written by the list resource API, and here's the content that gets returned if you invoke that read resource method against that, passing the URI of that resource, which is that unique identifier for that resource, right? It's returning all the contents of the resource along with the URI and the MIME type, I believe, right? So, all right. So that was about resources. Let's take a look at prompts next. So prompts, like we discussed, they're nothing but reusable question templates, and little more detail on how that works. Think of the template as a basic boilerplate thing, but obviously it needs some customization, right? So you have placeholders here which lets you customize that question. So let's say I've got a prompt that basically accepts, for example, two things: the language related. So let's say you've got a question and you want to understand how a code works, right? So typically you'll have some code sample, and then you'll also have what language that code sample is from, right? So you can plug in the language name and the code sample here in this prompt, and you can make a call to get it back. So let's say your server is registered this prompt with these placeholders. When you make a call to understand how what those prompts are, it will return you that information list prompts. The list prompts will have the name, description, arguments that it needs and what is required. So here it says the prompt name is explain code, and here's the description, and here's the output. So let's go back one second here. So we've got two arguments here. One is the code sample and the language here, right? So when we are making a call to get that prompt, we are passing those arguments here. So languages here is code fee and the code sample is this, right? So you get the prompt, you replace the placeholders with whatever you want to fit the prompt, and then you can use that prompt. It returns you that prompt, and then you can use that prompt to make your LLM call here. So show you an example for that. So let's say we've got TypeScript and ColdFusion. Let's go with this. So we've got two things here: summarize text and explain code. And here we have, I think this needs text, and at least one of these things are mandatory, right? So let's say we've got something here that works. So the second one is not mandatory, which is, I mean, it should be, but basically I'm passing the text part of it, which is the first one, I believe. Summarize the following text in the most max word text, right? So likewise, we've got some other prompts for in a TypeScript based server. Okay, so now let's take a look at sampling. So which is something that is a feature that is made available by a client. So client is something that says if it's I'm able to handle your sampling request, the server, the MCP server can make those sampling requests. Uh, so let's say in our use case where we have a trouble ticket processing system where we want to, let's say, make a sampling call back to the client to summarize the incident report, maybe, then the agent calls the this particular tool, which is basically this feature is exposed as a tool in this example here to simulate that, but we'll see how that goes. So let's say the server has all the context it needs, and it needs to summarize that request, that incident related to the trouble ticket, right? So it will basically make a sampling request back to the client, and the way it works basically is on the server side. There's a particular way in which it sends the message back to the client, and the client invokes services that request by gathering that information and making an LLM call or whatever it wants to do with that, and then returns it back to the server. So uh, that's a typical high level workflow. But if you look at the details, here's what happens. So uh, you of course have to advertise that capability as sampling here in your capabilities configuration for for the client, and you register that consumer function that basically is going to be handling your sampling requests. So when the request comes in, like we said, the server is going to send a sampling request, right? So this is, let's say, the request, right? So the kind of information that that request is expected to have is going to be basically these values, right? So you've got role, you've got the content type and the content text of that request. So, and the text can have, for example, in the context of our use case here, the text can have all the details for that ticket, right? Type can be what type it is, which is doesn't really make sense in this context. And it can send it can also make uh, suggest the maximum number of tokens that the client can use to be able to summarize it. So let's say this client is making an LLM call to summarize the contents of the ticket. It can choose to honor this max token limit request that was sent by the server, and keep it within that limit. And then it can also send what model it prefers. So it actually is asking the client to use this particular model, LLM model, to service this request, right? And system prompt as well. So system prompt is basically the kind of question it wants to ask that LLM, right? So, and when the client responds back to the server, it will do it in this typical form. So it will return the result in the form of a value for the result attribute of that struct, and then the model that it used. And so whenever you're making a call to the LLM, there's always a stop reason. It basically LLM's way of informing the entity that invoked it and the reason for it stopped the servicing the request. So that information is basically sent back to the server that raised that sampling request, right? So this was the server, this was the client configuration and how it was going to be servicing the consumer, right? And here it is in basically this is a simulated form where actually this particular client is connected to a server which is making a sampling request, and how it is making a sampling request by calling a tool. So this tool basically is raising that sampling request back to the client, and the client is then deserializing that response and just printing it. So it's a bit of uh, a round of a, a way, you could say, by in order to simulate that sampling request, we are making a call to the we are making a call to a tool, which in turn is raising a sampling request. So it's, you could say, it's a slight simulation, simulating that actual workflow, a use case, you I would rather say. So let's say here's the text that it wants to summarize, and summarizes via sampling, right? So this is going to send a sampling request back to the client, right? So the client receives it like this, and it can send the response back to the server in this manner, right? Right. So moving on to the other features of the I'd say client here. Logging is a server feature. So logging is basically something that, like we discussed, server can send logging messages to the client, and the client, if it has logging enabled, it basically means that the client can listen to log entries sent by the server, right? And like I mentioned earlier, we can set a logging level to filter the kind of entries or log notifications we want. So the MCP specification basically allows for the following, or rather, it suggests the use of the following levels, and here's how you will typically use it. Your consumer listener for the logging that is registered with your client can filter the messages here, right? So here it's doing nothing but just logging away those, whatever is being sent in this whatever the server is sending to the client is coming in the form of this message, and here it's just deserializing that message, or not, rather deserializing, it's just dereferencing the log level as well as the data that is coming along with that information. Okay, so elicitation is, like we discussed earlier, it's a way for a server to be able to uh, inquire, raise a small inquiry with the client if it needs some information, right? So uh, here's how it is done. So like it is in the case of sampling, you will have to advertise that feature as a capability with the client, and then you will be registering a handler. A handler is nothing that but a function that will be servicing the elicitation request on the client's behalf, right? So when the server makes a request, it sends it in the form of this particular argument, and you can decipher that argument and see what it actually needs, right? So in this case, what we are doing is basically uh, it's just responding with the request. So let's assume a hypothetical case where an elicitation request came from the server asking for the identity of the user that the client's original request pertains to, right? So here the client is responding back, giving the information that information back to the server, right? So it's returning username and the email address and the password for that user, right? And that request that came in from the server, it basically would have information in the form of this, which is username, email, and password, which is what it is, inquiring for. And when the client responds back to the server, it responds back with information along with this particular field, which is important in the sense that it informs the server that his elicitation request was accepted or declined, right? So you can set it to the appropriate value when returning the response, or you can it can have any of the three values. You can cancel it as well, and see if we can take a look at the sample for that. Uh, so elicitation here is basically returning that information back. It's saying that it accepts whatever the elicitation request is, and it's just kind of responding it with the same information for every request, which is not typical. Like you'll typically add more code here to return depending on the conditions, right? And let's take a look at the So this is configured with the same server that we saw earlier. Okay, I'm sorry. So this is configured with actually a TypeScript server, because now some of the features that we have in ColdFusion, they in ColdFusion in particular, the server does not support sampling or elicitation, which means that we'll have to use TypeScript based service to demonstrate this use case. Um, if I can take a quick minute to show that to you as well. Right. So here's your typical server that actually makes that elicitation request. Right. So you notice that this is the information that it is seeking: username, email, password, and this particular field. Okay. So moving on to roots. So roots are something that actually are basically resources that are made available by the client to the server, which means that let's say you have a certain directory that you want the server to be able to access. You can register that as a root with the client, and here's how you'll be doing it. So you have a method that lets you add the root. Root is, think of it as just a directory for our use case. In this case, it's a file, and then you are adding multiple files to it with specific names, and then this lets you basically list the routes that are available that you've already registered. And if you want to get the route, you'll basically be querying it with just the URI, and it will return the other details for the route. And if you want to remove a route, you can call this remove route method. Okay, so here's an example of what route we are adding here. We are adding this particular route here to the client, and this was registered as, it's a pre-configured route, which means that it's already there in the sample application. This basically added this particular URI along with this name, and the server can actually make a call to this particular route, and it can actually access the files here. So if it makes a call to read the route, it will be able to read the contents of this particular file, which is what you see here, which is basically the content of this particular file within this directory. Right. So moving on to the other miscellaneous features that we have. So we've got the feature that allows all along that we've been seeing the communication that is happening between the server and the client. That's basically open, but you can kind of limit it by using uh, a basic authentication mechanism that is supplied. So if you configure your MCP server with uh, a username and a password, it will be restricted. So whenever a client is making a call to this server, it will have to pass these credentials for it to be able to talk to the server. Now, here I'm just hard coding the password, but obviously you will be using a more sophisticated mechanism, like maybe reading it from the environment variable. Now when the client is making a call, you would be passing this the credentials back to the server in this particular form. So you have to basically convert it to base 64, and you have to pass it in this particular format where you're using username colon and the password here, right? So all you do is basically send that as an authorization header with your HTTP request. And obviously this is applicable only to the HTTP transport protocol when you're using the client server communication here, right? So other than that, we've got a mechanism that lets you allow different domains as well. So within the server, you can configure a setting called course. So course is basically the same thing that if you've been to a website and if you check out your browser debugger, basically there are rules. So if you set the course rule to a wildcard, it can basically be accessed by any domain. But if you restrict it, it can only be accessed within the same domain. So it's a very commonly used security feature, and by default it is enabled, or rather it is disabled, which means that you cannot, if you're using a browser, it's a rule that is enforced by a browser, which means within the browser, if you've got a JavaScript or a code, a JavaScript based code that is making a call to an entity that is outside the domain from which that page was loaded, that browser will request that call, right? So if you happen to be using this server, you're accessing the server in a JavaScript or a code that is directly accessed, processed by the browser, you can set this particular setting so that your code can make a cross domain call to whatever domain you've configured in this particular rule here. Okay. Now, whitelisting is another security feature. It's basically something that allows you, when you're using the stdio based uh, mechanism, you can restrict which calls you're making, or rather, you can restrict which processes you're allowing within that request, right? So, if I can show you that again back, maybe I think I had it somewhere in the slide. Right. So here, what we are doing here is we are whitelisting let's say we are using the node command here, and we need to whitelist the node command. So if we did not have this in the whitelist field here, this code would not function because it is not whitelisted. So anything that you're using here has to be whitelisted. It makes sense. So for example, if you're exposing this client object for a wider use case where you are accepting this as an input, using a variable here, and this field is dynamic. You can control the kind of uh, uh, permissions, or other you can control what is being executed when this or rather being set, how that dynamic variable is being set, by kind of controlling it or limiting it with this particular parameter, which you can have as a fixed value, right? So that's what whitelisting is about. It's basically a security feature. And there's something called max request body size, which is a way for you to restrict the kind of response that server is uh, i- the size of the content with which the server is responding. So let's say if it is uh, if it is fielding a request from a client that is greater than the specified limit, which is in bytes here, obviously, then it will error out basically. So the client has to make a call which is within this limit. Right. So we've talked about the different features of MCP, and we've talked about how to configure things and how to use it in the context of applications. Now let's take a look at how some other things. So basically, when you're using it in the ColdFusion context of ColdFusion, you will typically be using it using the ColdFusion administrator, where you'll be setting multiple servers, right? So there are two different ways you can register multiple servers in one go in ColdFusion. So one is something called bulk loading using JSON files. So we've got a parameter called uh, it's a config file here, which basically allows you to specify the JSON file, which has a bunch of different parameters, right? So let's say you've got a JSON file. You've got a list of different JSON servers. So let's say it's not just ColdFusion. So let's say your ColdFusion server can talk to any MCP server, right, outside the ColdFusion as well. So you may have that in the form of a JSON file, where you've got a list of URL based MCP servers or STDIO based MCP servers. You can just take that JSON and feed it into this particular API, and it will basically register all those servers with ColdFusion, right? So in this particular case, it is getting used directly in the application. So this there's two different variations of MCP client API. So MCP client API basically will return you a single MCP client object that you can call all those methods like list tools or invoke tools or rather call tools against. But if you're passing the config file parameter where you're passing multiple servers, the MCP client API is going to return you an array of objects, array of MCP clients that gives you a handle to each one of those servers, right? So you will have to dereference the returned array and invoke the applicable client to talk to that specific server within that array. Okay. So that's how bulk loading works within an application at runtime, or rather, when you're doing it directly in your CFML code. But you have an option of doing it in administrator. So let me show that as well. I think I had a slide for that, but I'm missing it. So I'll show it directly to you in my browser, where I've got a running instance of ColdFusion here, which I think I have configured with uh, MCP server. So this particular new release, you'll have this new tab, which if you're a part of the beta program, you should already be familiar with this UI. So we've got a bunch of different, all the AI features that we're exposing, they're all now have a dedicated panel, or rather tile to it, right? So you've got a bunch of different pages here. There's one dedicated specifically to MCP servers, right? So here with this page, it allows you to basically register all the servers that you might want to expose, and you want your applications to have at a highest level, right? So whatever you set here, it gets set at the server level, and unlike the code that you have that you're using in CFML, you recycle the server, all that disappears, right? So if you register it here, it gets persisted to that new XML file that we have. Your typical Neo file that we have in the lib folder. It resides there. Every time you restart it, it'll be back with you. So you can basically reuse it over server restarts or server recycling, right? So here's how you add it. You click on the add button, and the same JSON that I showed you earlier, you can specify it here in this form. So here I've got a mix of two different instances. I've got a STDIO based server as well as an HTTP based server registered here. They both happen to be on the same host that I have here. Here's this refers to a specific TypeScript process, or rather, what will become a process when it gets invoked. And the second one is a CFM template within the page within this particular server, right? So once you register it, you can do things like, you know, stop it, disable it rather. The one advantage of having it is you can disable it, and if you click on this, it actually will give you a listing of all the tools that are available with this particular server, right, along with the parameters that it accepts, and return type as well, which we don't have here, but maybe we have it here. Okay. Which I'm not sure if this method has a return type. Actually, it does. So I think we get that in the listing, but I'm not sure about this thing here. Anyway, so it tells you the status of it. It's connected. You can stop it to disable it, I believe. So that disables it, and that hopefully enables it. If I guess I have to refresh it. Okay, so there you go. It's back. So right, so all you have to do is persist that add the configuration in the JSON form in this file here. Okay, and like all the other pages that we have, admin pages, if you've got a UI, you've got an admin API as well. So you can use the admin API to process this information as well. So which is, you can do this programmatically as well as using that browser UI. When you're doing it programmatically, you will be using this particular CFC, which is an admin API CFC just for MCP. You get a handle to it. It's typical after typical admin login, and then you pass the JSON content to it. Here, I'm just reading it from a file and making it back into a string and passing it along. And calling this function basically will write it to your new XML file, and it's going to be there forever with your server until you remove it, delete it, or right. So basically, it returns two things. It returns whether this uh, action resulted in if it was a success, and the second thing is if there's errors. So can register multiple servers. If there's one server which is not working, then you'll have that information why it's not working in the form of an error string here. Right. So we've talked about how you can register your LLM service, or rather, we've talked about all the MCP features, but we've not talked about how to actually use it with an LLM service, right? So when you're creating a client that is connected to a server that has a bunch of tools and resources and whatnot registered with it, obviously you need some sort of a way to make use of that in the LLM call that you're making, right? Now, when you're using ColdFusion, I'm not sure if you've attended the previous sessions that we've had, I believe yesterday. So we talked in detail about how to make those LLM calls, right? So I'll be only touching upon very briefly on how to do that. But if you want a detailed understanding of the how that works, you'll have to go back and listen into the presentation that was, uh, I believe, telecasted yesterday, right? So now let's take a look at how that works here. So we've got two methods. One called, rather, we'll have two config. One method called agent that makes use of uh, the chat model object. So when you're making an LLM call, there are a few things you need to configure. One is which model provider you're going to be using with your call, and what is the model name that you're going to be invoking. And obviously, you'll have to pass along your key that you have in order to access the service along with this configuration, right? So you call the chat model API to get an object that you can use in the subsequent agent API call, right? So once you have configured that, then you can make a chat request. Chat request is nothing but your query. So like we discussed, we talked about how the prompts work. So here you can raise a prompt, or you can configure your question with the service by calling the chat method. So chat method is what you'll be passing the user prompt. So if you have as a user, you're asking a question, you can pass that in this particular API. But before that, you have to set, let's say, the identity of the model that you're invoking, right? So when you're talking to a model, it's best for you to, to get the best out of that response. You have to define how that model should behave, or what kind of role is expected of that AI service. So you kind of uh, paraphrase that in the system prompts. You tell what your AI service is supposed to do in this particular message. So in our use case, you're going to be making it into some sort of a ticket classifier and processor, and you typically would be a very elaborate description of what it is supposed to do. And then once you've got that set, you can raise a query, and then it will process that query within the context of this particular system message that you've set, right? So now all that apart, if you are doing that and you want it to use some sort of a tool based MCP server that you've configured, here's how you'll do it, right? So this is the key part. So you'll be providing the MCP client object. You'll be configuring that along with the API. So this basically tells the agent API to make a call to the server using and allow it to use the tools that are configured with this client here, right? and here's the final code. So in this particular example here, we are not using the configuring the MCP client with the tools here. In this case, we are, right. So this, in the second case, if the LLM would be aware of what clients, what kind of tools are registered with the client, and if it needs to call those tools directly, it will have the option to do that. Right. So here's a code sample on how you'd be doing that. So basically, here we've got this client sample of the client that is connected to the server, and here we've got the chat, or rather the agent API that we are invoking, configuring that client that we've just configured in this particular section here, right? So I think that brings us to the conclusion of our presentation. Let's take a quick look at the time permits. We'll take a look at some of the other sample that we have. So let's say we've got what I have here is basically a system that actually processes the ticket that we initially started with. So let's say we've got different trouble tickets in the form of let's say mm, so I've got a set of JSONs that basically have a description of what the issue is about, and we're going to be processing that here with this application. Let me go back and show it to you in the. So here we are simulating almost everything, which means that the information I have is encapsulated in the form of a JSON, and we've got a bunch of information which is like the documents that can be referenced by the MCP server, or rather can be accessed by the MCP client here in the form of KB articles. And we've got say a trouble ticket in this. So this is the input for the application, where let's say that let's take a look at this thing here. So we've got a ticket with an issue statement of an issue, where you've got uh, a memory outage of some sort, and this application needs to process it. So okay, so let's say so the first step basically retrieve the ticket. The second step is trying to classify the ticket based on the information that was contained in the JSON, and it's going to make a LLM call for that, and then the subsequent step basically require it to just give me a second. I think I'll have to set this thing. Right. So this is the summary of the response. Now, if we take a look at the systems here, so I've got different CFCs that. So here's the just taking a look at the example for the incident summarizer CFC. Here it's is going to make a call to agent here with this information. This is your typical system message where you're setting it, giving it a specific role, and then here you're raising a query about how to summarize this what to expect. Rather, it's asking it to summarize the incident by supplying it all the information, and then chat request. So all this information is passed on as a user message, a prompt to the user message, and this basically is something that specifies in what format the response from the LLM is expected. So after you raise a request, it's going to return this particular information, right? So the next step is supposed to search the knowledge base, and it's basically a stepwise process on how you can go through each of those steps in a sequence by leveraging the functionality that is built into as an expose as MCP components or MCP tools here. And there's one feature wherein you can just make a quick call with the auto agent configured, which means that you throw everything at the LLM and you let it process the request and uh, return the response with all those steps applied. So that can have behavior depending on it can have different outcomes, and so it's not always very consistent because every LLM call is going to have a slightly different output, I would say. So there, if you could check out the prompt that we have. Right. So this is the prompt that we are sending to the for the auto uh, flow, where we are just asking it to take all the steps. So it's important for you to configure your system message properly. That gives it the instructions to the LLM service on how to service your request. And here we are asking it to be that an AI powered intelligence support system, and we are telling it what kind of tools is registered. We're registering like 1, 2, 3, and 4 tools here. The first tool, of course, returns details for the ticket that we're inquiring about. Then it tells that it has access to the tools to get the logs, which we are simulating in the form of some documents here. And then we're giving it access to the knowledge base as well. And then finally, a tool that once the LLM is done processing all the requests and it has an option of calling this tool with the information that it processed and kind of churned out, and then it can be the final outcome of the steps. So this apparently the final response has been successfully triaged and escalated to high priority, right? So that was a basic brief rundown on all the features, what the kind of features that we have with the uh, MCP component of the different AI services that have come up with this new release. So to briefly give away the points that we've covered so far, we've talked about what MCP is in general, and then we've got covered about the basic features that are exposed at the client level and the server level. We've talked about the different workflows that kind of entails with each of these features. Then we've talked about how to configure the tools with your typical agent call in a ColdFusion application. And we've touched upon some basic security features that we have in the context, specifically in the context of just MCP when you're using MCP, along with the various admin APIs and the administrator that you can use to configure your ColdFusion. I think that brings us to the conclusion of our presentation. Let me go back and see if we have any questions.
Awesome. Thank you, Piyush. Yeah, there were a couple of questions. I think CF Dynamics asked early on about security, which you did cover, primarily about prompt injections, poisoning, fatigue. Are there ways to guardrail inside of MCP directly, or like how would you prevent some of that from happening to your MCP server?
Guardrail is something that you'd use in the context when you're making an LLM call. Everything else, so guardrails is something that lets you control how the LLM is going to process your information, right? But if you have an MCP server and a client, you basically are in control of anything that is coming your way, right? So I think you should
Mhm.
be able to handle it yourself, right?
Okay. Yeah, that's kind of what I was thinking. The other question was, William was asking about the code for this. I know we're planning on putting this code out onto our GitHub. He was wondering approximately when we thought it would get out on the GitHub, and I already put the link up to our Adobe ColdFusion GitHub. But do you know like when you're planning on posting stuff up there?
So we had two different code sets, right? One was where I was demonstrating the features with those tabs on the top, right? And the second one
Mhm.
was where I was talking about the intelligence system, right? So the intelligence system needs still needs some work, I'm afraid. So
Okay.
yeah, so, sure, I can share it, but I would prefer to get all that working first. So yeah, definitely
It might
we can.
So it might be a minute, but we'll have it up. We'll have it up on our GitHub,
Yeah.
William, as soon as we can. Awesome. Well, thank you, Piyush. This was awesome. Great talk. I learned a lot. And by the way, this has been recorded. In fact, I'm going to go ahead and stop the recording. Um,